Hello everyone, welcome to Learn Online. In today's session, we'll be seeing problems on trigonometry from our previous year SSC question papers. As you all know, this is our third session on trigonometry. People who haven't watched our previous two sessions, please do go back and watch our previous two sessions. It is available for free on YouTube, the link for which will be provided in the description of this video. The reason why I am telling you to watch our previous two videos is, especially the first session of ours contains all the basics that you need to solve the questions in this session. In today's class, we'll mainly be looking at problems related to complementary angles in trigonometry. What do you mean by complementary angles? If I have two angles, for example, let me say angle A and angle B, when can I call that these both angles are complementary to each other? I can tell A and B are complementary only when the sum of both the angles gives me 90. So for you people to understand this better, if I take the value of A as 23, then what should be the value of B so that both the angles become complementary? It is very easy. You know that the sum of them, let me take this as B itself, sum of them should give me 90. So value of angle B must be 90 minus 23. That is nothing but angle B is 67 degrees. So you can call 23 degrees and 67 degrees together as complementary angles. In our first class, I have already told you that the values of sine, tan and cosecant theta, if they are moving about 90 degrees, 90 plus or minus theta, then sine will change its value to become cos. Similarly, tan, cos, if it is moving about 90 degrees, it will change its value to become sin theta. Similarly for tan as well, if you get some value as tan of 90 plus or minus theta, you can directly write it as cot theta. Similarly, if you get any values as cot of 90 plus or minus theta, you can write it as tan theta. For cosecant theta, it is nothing but secant theta. For secant theta, it's cosecant theta. What do I mean by this? If I have a value something like this, sine of 23 degrees. How can I write this? I can also write this as sine of 90 minus 67 degrees. So what can I write? Sine of 90 plus or minus theta? I can write it as cos theta. So the value of theta here is 67 degrees. So I can write this as cos of 67 degrees. And what does this mean? It means that sine of 23 degrees is equal to cos of 67 degrees. This is nothing but we are revising whatever we have learnt in our first video here. So using this, we'll be solving the problems in today's class. Now let us look at our first question for the day. What does it say? Or it is 11th question when I'm counting my previous video as well. So what does it say? It's telling that if x cos 45 degrees is equal to y secant 60 degrees, then find the value of x power 4 divided by y power 4. So let me quickly substitute the values for cos 45 and secant 60. What is cos 45? We all know that cos 45. So x into value of cos 45 is nothing but 1 by root 2. Now, what is the value of secant 60? Which is equal to y into secant 60. And the value of secant 60 is nothing but 2. So now, what they are asking? They are asking for x power 4 divided by y power 4. Meaning, let me take x and y to one side. So, I will be left out with x divided by y will be equal to 2 divided by 1 by root 2. What will happen? 1 by root 2 will go to the numerator. So, what will I be left out with? 2 power root 2. X by y is 2 power root 2. Then x power 4 by y power 4 doesn't. What does it mean? It means that x by y the whole power 4. Doesn't this mean the same as this? Yes. So now, what will I be getting here? I'll be getting 2 root 2 the whole power 4. So now, what is the value for 2 root 2 the whole power 4? It is nothing but I can also write this as 2 power 1 into root 2 can be written as 2 power 1 by 2. The whole power of 4. So now if I use the laws of indices, what will I be getting here? 2 to the power 3 by 2, the whole power 4. So now again using the laws of indices, I will be getting 2 to the power 6. And this will be the value of x power 4 by y power 4. Do we have this in our options? So there is no options of 2 power 6. There is value of 2 power 3. So this is not my answer. So now I'll have to write it in a different way. So how can I write 2 power 6 as? I can also write 2 power 6 as 2 square the whole power 3. Because whenever you are using laws of indices, 2 power 2, the whole power 3 is nothing but 2 power 2 into 3. That is nothing but 2 power 6. This is the same here. So now what is 2 square? 2 square also be written as 4 whole cube. Now do we have that in our options? Yes. Option A, 4 power 3 will be our final answer. So now let us look at our next question here. In this question, we'll be using the concept of complementary angles. First, let me give you a small example so that you understand the concept written in it. So now, if we have some value like this, what is it? 2 into 3 into 4 into 5. What will be the value here? The value will be nothing but 2 into 3 is 6. 6 into 4 is 24. 24 into 5 is 120. Similarly, if I rewrite this as 2 into 5 into 4 into 3, what will be the value of this? 2 into 5 is 10. 10 into 4 is 40. 40 into 3 is nothing but 120 only. Look at this. The value here do not change no matter how I rearrange it whenever there is multiplication or addition between the two terms. So we'll be using this concept as well. So according to this, if I rewrite it as cot 1 degree into, instead of writing cot 2 degrees here, I'll be writing it as cot 89 degrees. I'm getting this 89 degrees and rearranging it here. Similarly, I'll write cot 2 degrees as it is, and then I'll write cot of 88 degrees. And so on it continues. Now, what did I tell you? When can you call two angles as complementary angles? Whenever the sum between those two angles is 90 degrees. So what is sum of 1 and 89? The sum of 1 and 89 is nothing but 90 degrees. Which means 1 degree and 89 degrees are complementary to each other. So how can I write cot 89 as? I can also write cot 89 as. Let me write cot 1 degrees as it is. So now into, I can write cot 89 degrees as cot of 90 degrees minus 1 degree. Am I right? Because 89 is nothing but 90 minus 1. It is the one and the same. Similarly, I write cot 2 degrees as it is, and I can write cot 88 degrees as cot of 90 degree minus 2 degree. So now, as I told you, if the value of cot is moving around 90 degrees, that is 90 plus or minus theta, what will happen to it? It will change to become tan theta. Look at this here. There is cot of 90 minus something, meaning this will turn to become tan of 90 minus theta, or I mean tan theta. What is the value of theta here? Theta here is 1 degree. So this entire equation will become cot 1 degree into tan 1 degree into, write cot 2 degrees as it is. Similarly, the value of cot of 90 minus 2 degrees will become tan of 2 degrees. Now, instead of considering all the pairs here and so on, there will be n number of pairs. We don't know how many pairs yet. So instead of considering all these pairs, I'll just consider this one pair here and this as one pair here. So what will be the value of one pair? Let me solve for each and every pair separately. So now what will be the value of cot 1? we know that from our previous video, cot 1 degree can also be written as 1 by tan of 1 degree, because cot is nothing but inverse of tan. So now I can rewrite this equation as 1 by tan 1 degree into tan 1 degrees as it is. What will this be equal to? This will get cancelled and I'll be remaining only with 1. So the value of this pair here will be 1 into value of this second pair will also be 1, because they are nothing but complementary angles. They are same angles, so I can replace them like this. So the value of each and every pair here will be 1, 1 and 1. So now, how many pairs do I have? How many pairs can I form there? So there are totally how many terms here? There are totally, it will start from 1 degree and end at 89 degree. Meaning, there are 89 terms. So there's 1 degree into 2 degree. I'm neglecting cot here. 3 degree. Up to, there's something called as 45 degrees here. And then, there is something called as 87 degree, 88 degree and 89 degrees. So before 45, how many terms are there? There are 44 terms. And after 45, how many terms will be there? Again, there will be 44 terms. Now, you know that two terms which are complementary angles will give you the answer of 1. So, there are how many pairs here? There are 44 pairs. One term from this, one term from this. Meaning, two terms will form one pair. So, similarly, there will be 44 pairs and 45 is the middle term. It will not form any pair. So, the value will be 1 into 1 into 1 for 44 times into cot of 45 degrees, because this is the middle term and it is not forming any pair. So, what is the value of 45, cot 45? Cot 45, we all know that value of cot 45 is 1 degree. 1. It's not degree, it is 1. So, what will be the total value? It will be 1 into 1 into 1. So, if you multiply 1 n number of times, what will be the answer? The answer will be 1 only. Do we have this in our options? Yes. Option A, 1 will be my final answer. So, now let us look at our next question here. What do we have for the next question? They're asking us to find the value of tan 41 into tan 42. It's very similar to the previous problem. So, quickly let me rearrange. So, what do I have here? Tan 41 into tan 49 into tan 42 into tan 48 and so on here. So now look at these two terms here, 41 and 49. What is sum of 41 and 49? 41 plus 49 gives me 90, meaning they are complementary angles. Since they are complementary angles, I'll write it down as, I'll keep tan 41 degrees as it is and I'll write tan 49 degrees as tan of 90 degrees minus 41 degrees. Because they are complementary angles, so I can directly write it as 90 minus 41 into tan of 42 degrees into tan of 90 degrees minus 42 degrees. So now again, similarly, I'll consider this as one pair, these two as one pair. Now I know that tan of 90 minus 41 can also be written as cot of 41 degrees. So what will be the value here? It will be tan 41 degrees into cot 41 degrees into tan 42 degrees into cot 42 degrees. So, these two are one pair here and these two are one pair. What is the value of this pair here? We know that tan into cot is nothing but 1, because cot can be written as 1 by tan. Tan and tan gets cancelled because they are same degrees, 41 degrees. So, it is theta. You can consider this as cos tan theta and cot theta. These are 42 degrees. Both are 42 degrees. So, you can consider as alpha and alpha. So, tan alpha into cot alpha can be 1. Tan theta into cot theta is 1. So, tan into cot will be 1 whenever the angles are same. So, value of one pair is 1. Similarly, Second pair is also 1. Since there is multiplication, I can write 1 into 1 into 1. N number of times it will be 1 only. So what am I left out with? I'm left out with how many pairs can I form here? They are starting from 41 up to 49. So there are totally 9 terms. And which is the middle term here? Middle term will be 45 degrees. There will be 41, 42 degrees, 43 degrees, 44 degrees, and middle term will be 45 degrees. So after 45 there will be 46 degree, 47 degree, 48 degree and 49 degrees. Now we know that 41 and 49 degrees form a pair. So 41 and 49 here is forming a pair and value of this pair is 1. Similarly, 42 and 48 are forming one pair. 43 and 47 are forming one pair. 44 and 46 are forming another pair. So what is the term which is left out without a pair? 45 degrees. So 45 degrees is left without a pair and each other pair value is 1. How many pairs are there? 1, 2, 3 and 4 pairs. So this will be 1 into 1 into 1 4 times and tan 45 degrees remains as it is. What is the value of tan 45 degrees? We all know that tan 45 is equal to 1. So other 4. So how many ever times you multiply 1? The final answer will be 1 only. So do we have that in our options? Yes. Option C, 1 will be my final answer. Now let us look at our next question here. This question is also similar to our previous question. We'll be using the concept of complementary angles here. But there is a little twist in this question. So what is it? We know that whenever there is multiplication, I can rearrange the terms. So I'll quickly rearrange it. What can I write it as? I can write it as cos of 12 degrees into, which is the complementary angle for 12. 12 plus 72 gives me 90 degrees. So complementary for this is 78 degrees. So I'll search for 78 degrees. There is 78 degrees here. So I'll write this next to it. Cosecant 78 degrees. So now, what do we have next? I have cos of 48. I'll write it as it is. Cos of 48 degrees. What is the complementary angle for 48 degrees? Complementary angle for 48 is nothing but 42 degrees because 48 plus 42 gives me 90 degrees. So which is the term which has 42 degrees? Cosecant 42 degrees. Cosecant 42 degrees. Now what is the remaining term here? Remaining term here is sin 30. And sin 30 does not have any other pair. So now look at this. I'll consider this as one pair and consider this as my second pair. And sin is a lone warrior here. It doesn't have any pair. So we know that these are complementary angles. And now instead of writing it as cosecant 78 degrees, I can also write it as cosecant 90 minus 12 degrees. So here cos 12 degrees as it is. Similarly here as well, cos of 48 degrees as it is into cosecant 90 minus 48 degrees and sin 30 degrees as it is. So now, what is the value of cosecant 90 minus theta? Cosecant 90 minus theta is secant theta because it is moving around 90 degrees and cosecant changes to secant. So cos 12 degrees into secant 12 degrees into what is the remaining? Cos 48 degrees into cosecant 90 minus 48 can also be written as secant 48 degrees. And which is my lone warrior here? Sin 30 degrees. Now look at this. From our previous class, we know that what can I write secant as? Secant is nothing but inverse of cos. So secant theta is 1 by cos theta. Value of theta here is 12 degrees. So what can I rewrite this as? Cos 12 degrees as it is into secant theta can also be written as 1 by cos 12 degrees. Similarly for this as well, cos 48 remains as it is into 1 by cos of 48 degrees into sin 30 degrees. Now what happens? Cos 12 degrees gets cancelled. Similarly for 48 degrees, and what will I be remaining with? I'll be remaining with sin of 30 degrees. So now what is the value of sine 30? This is nothing but 1 into sine 30 degrees. What is the value of sine 30? Sine 30 is nothing but 1 by 2. So my final answer will be 1 by 2. And do we have that in our options? Yes. Option B, 1 by 2 will be my final answer. Now let us look at our next question here. Next question is a very simple question. As soon as I look at the question, I can tell you that the answer is 0. But then, how did I tell the answer is 0 even without solving the problem? They're asking cos of 1 into 2 into 3 into so on up to 120 degrees. So there is cos 1 degree into cos 2 degrees and so on. In between, there is one value that is nothing but cos of 90 degrees. And then there is into cos of 120 degrees. So 90 degrees lies between 120 and 1. So we all know what is the value of cos 90 degrees. The value of cos 90 degrees is nothing but 0. 0 into any number gives you what? 0 only. So I need not solve for any other term. I can directly write it as 0. So what will be my final answer? My final answer here will be 0. So look at this carefully, people. Whenever you are finding something like this, cos of 90 degrees or sine 0 degrees, whenever you have multiplication, directly write. Whenever there is only multiplication involved and you find values like this, that is cos 90 or sine 0 or tan 0, you can directly write the answer of the solution, answer of the entire equation as 0. Provided there is multiplication throughout, because 0 into any number gives you 0. So now let us look at our next question here. It is similar to the previous question, but then the values are increasing in terms of 5. So what is happening? Let me consider that instead of dealing with degrees, let us deal with money so that you can understand it better. So what is the final term here? 90. So let me tell, you have 90 rupees in your hand. So you have notes in your hand. So value of each note is 5 rupees and totally you have 90 rupees. So how many 5 rupees notes you will have? One 5 rupee note will be 5 rupees. Two 5 rupees notes will be 10 rupees. So similarly, how many 5 rupees notes will give you 90 rupees? That's nothing but 18 5 rupees notes will give me how much? 90 rupees. Similarly, if instead of rupees, if we start dealing in degrees, what is happening? 1 5 degrees will give me 5 degrees, 2 5 degrees will give me 10 degrees and 18 5 degrees will give me 90 degrees. Meaning there are how many terms here? There are totally 18 terms. If there are 18 terms, which is the middle term? We don't know which is the middle term. So if there are 18 terms, I'll take sine 45 degrees as to be my middle term here. Then how many terms will be before this? Totally there are 18 terms. So there will be 8 terms before this and this will be my 9th term. And there will be 8 terms after this. So then how many terms will I have in total? 8 plus 8, 16 plus 1, 17 terms. Which is the other value that is there? Totally I have 18 terms. I have got only 17 terms here. So which is the last term that I'll have? Sine 90 degrees. So which is the complementary angle for sine 90 degrees? 90 degree complementary angle is 0. But then do we have 0 here? No. We have only 5 degrees. It is starting from 5. So again, sine 90 will be my lone warrior. So which is the complementary angle for 45 degrees? Complementary angle for 45 degrees is 45 degrees only. But then I have only one 45 degrees here. I don't have another 45. So here again this will be my lone warrior here. So totally how many pairs can I form here? There are 8 terms here. There are 8 terms here. And 2 terms together will form 1 pair. So totally how many pairs can be formed? Totally there can be 8 pairs that will be formed. So if there are 8 pairs, what's the other remaining ones? It is sine 45 degrees and sine 90 degrees. Now, what will be the value of one pair? Let us quickly solve that. So what I have? Sine square 5 degrees. And what is the complementary for this? Plus sine square 85 degrees, because 85 and 5 are complementary, plus sine square 10 degrees plus sine square 80 degrees, and so on, plus so on. So two terms here will form one pair. How can I write sine square 85 as? I can also write it as sine square 90 minus 5. So it will be, they are complementary. 90 minus 5 meaning it will become cos. So sine square 5 degrees plus cos square 5 degrees. So value of this will be sine square theta plus cos square theta is equal to 1 from our identity. Similarly, this pair will give me 1. So there are how many pairs in total? There are totally 8 pairs. So what will be my answer here? It will be 8 pairs into value of one pair is 1 plus, because 1 plus 1 plus 1, 1 pair 1, 2 pairs 2, 3 pairs it will be totally 1 plus 1 plus 1, that is 3. Similarly for 8 pairs it will be 8. That's what I've got here. Plus there are two lone warriors here. Which are those? They are sine 45 degrees and sine 90 degrees. Now we all know that what is the value for sine 45? Sine square, sorry, this is sine square 45. Sine square 45, because in the question we have squares and not sine. So what is the value of sine square 45? Sine 45 is 1 by root 2. So sine square 45 is 1 by root 2 the whole square. Plus what is the value of sine 90? Sine 90 is 1. So sine square 90 is 1 square plus 8. So what is the total value that I'll be left out with? 8 plus 1 by root 2 the whole square is nothing but 1 by 2 plus 1. So totally I'll be left out with 9.5. And do we have that in our options? Yes. Option D, 9.5 will be my final answer. Let us look at our next question here. It is slightly complicated compared to the other questions that we solved. Why is it so? Let us start solving. We have here multiplication, subtractions as well. We have two signs here. First, they have given sine square 67 into tan square 23. How do we write this? There are 67 and 23. What is 67 plus 23? 67 plus 23 is 90 degrees. Meaning these two are complementary to each other. So instead of writing it as secant square 67, I'll directly write it as secant square 90 minus 23 degrees and into tan square 23 degrees as it is. Then what will I be remaining with? Sine square 38 degrees minus sine square 52 degrees minus tan square 23 degrees. So now, how do I go about this? First, what is secant square 90 degrees minus 23 degrees? It is nothing but cosecant square 23 degrees into tan square 23 degrees minus. Now, I'll take this sine 38. Look at this 38 and 52. So, they are complementary to each other. Instead of writing it as sine square 38, I'll write it as sine square 90 minus 52 degrees minus sine square 52 as it is minus tan square 23 also as it is. Now, what will I be left out with? Cosecant square 23 degrees. Okay. Cosecant square is nothing but inverse of sine square. So, I can write this as 1 by sine square 23 degrees into, how can I write tan square as? Tan square can also be written as sine square 23 degrees divided by cos square 23 degrees. Now again, minus, what is this? Sine square 90 minus 52 can also be written as cos square 52 degrees minus sine square 52 degrees and tan 23 degrees as it is. Tan square 23 degrees as it is. Now look at this. Sine square 23 degrees and sine square 23 degrees gets cancelled. Now what am I left out with? 1 by cos square 23 degrees. What is 1 by cos? 1 by cos is also be written as secant square 23 degrees. Now I will take this tan square 23 and arrange it here. So I will be left out with tan square 23 degrees. I'll take minus common from these two. What will I be left out with? Minus of cos square 52 plus sin square 52 degrees. Now, from the important identity that I've told you, what do we have? We have that 1 plus tan square theta is equal to secant square theta. Now, what will be 1 equal to? Secant square theta minus tan square theta. Similarly, from our first identity, what do we have? Sin square theta plus cos square theta is equal to 1. From these two, what can I write? Secant square theta minus tan square theta. Secant square theta minus tan square theta is 1. We have this minus here. Minus cos square theta plus sin square theta is nothing but again 1. So that will be 1. What do we have? 1 minus 1. Nothing but. What do we have for final answer? 0 will be my final answer. Do we have that in our options? Yes. Option D, 0. Now let us look at our next question here. What do we have in the question? Cot 66 into tan 66 into the old brackets there. Tan 66 into cos square 42 plus 1 by cot 66 degrees into secant 48 degrees. Don't get scared looking at the question. This question here is very easy. So how do we go about this? First, I'll multiply my cot 66 inside throughout the bracket. So what will I be left out with? Cot 66 degrees into tan 66 degrees into cos square 42 degrees here. Plus, if I multiply this, what will I be left out with? Cot 66 degrees, the whole divided by cot 66 degrees into secant square 48 degrees. This is nothing but secant square 48 degrees. Now, how to do this? You know that cot into tan is nothing but 1. Cot and tan gets cancelled because cot can also be written as 1 by tan and the angles are same. So I can directly cancel this out. Now here as well, we have cot divided by cot. So we can directly cancel them. Now what am I left out with? Cos square 42 degrees plus 1 divided by secant square 48 degrees. Now how can I write by 1 by secant square 48 as 1 by secant square 48 is also nothing but cos square 48 degrees. So plus cos square 48 degrees. Now 42 and 48. Look at this. What is 42 plus 48? It is 90. Meaning they are complementary angles. So how can I write my cos square 48 as? I can also write it as, I'll write this cos square 42 as it is plus cos square 90 minus 42 degrees. So finally what will I be left out with? Cos square 42 degrees plus sin square 42 degrees. Now what will my final answer be from the identity? Cos square theta plus sin square theta is equal to 1. So my final answer will be equal to 1. So do we have that in our options? Yes. Option C, 1 will be my final answer. Let us look at our last question for the day. What do we have here? Secant 36 degrees is equal to A and cot 54 degrees is equal to B. Then they're asking to find the value of A square minus B square. What is A square here? If A is secant 36, A square will be secant square 36 minus B square. What is the value of B square here? If cot 54 is equal to B, then B square will be cot square 54 degrees. Do we have any identity relating with secant and cot? No. We have an identity relating secant and tan. So what can I write this as? I can write this as secant square 36 minus cot square of 90 minus 36 degrees. Because 36 degrees and 54 degrees are complementary to each other. So what will I be left out with? I'll be left out with secant square 36 minus cot square 90 minus 36 is nothing but tan square 36 degrees. So now, what do we have the value for secant square theta minus tan square theta? Secant square theta minus tan square theta is nothing but 1. So do we have that in our options? Yes. Option D, 1 will be my final answer.